Today's location is a hop, skip and a jump away to the North Island of New Zealand. It's a rather fascinating little area known as Castle Point. This area was a bit of a geological puzzle for a time, but after thorough examination over the decades, the local rock people have come up with an answer. The rocks we're looking at are early Pleistocene in age, roughly 2.2 million years old. They are a mix of limestone coquinas and shelly sandstones. Just shells, fossils, pebbles and sediments almost everywhere you look. The first part of the puzzle was, how does something like this form en masse? The second part of the puzzle came after examining the shells. This mishmash of fossils includes species found in both warm and cold water, and species found in shallow marine environments and deeper marine environments. So how on earth do you get such an accumulation of species from so many different types of marine environments? Now, sea and ocean floors are actually incredibly fascinating places with their own ecosystems, features and terrains. Often when part of the sea or ocean floor gives way to a deeper part of the sea or ocean floor, you can get all manner of features forming along the sloping edge. One such feature is a submarine canyon. These canyons are like very, very steep valleys that can extend quite far along continental shelves. Now, New Zealand is fairly unique in that it's a raised portion of a submerged continent, so most of the continental shelf margins are elsewhere. However, the east edge of the North Island gives way quite sharply to the Hikurangi Trough, so here you would find all manner of features, including submarine canyons. And what can happen along the edges of these submarine canyons is that sediments and debris can build up through the movement of water and gravity. Over time, it is thought that the weight of this accumulated material can cause weaker layers in the canyon to collapse, resulting in a submarine landslide down the canyon. While on its way down, all the debris and sediments can take material from the sides of the canyon, as well as burying or throwing anything at the bottom of the canyon. And that is exactly what is thought to have happened here, providing a solution to the geological puzzle at Castle Point. The fossils from shallower and warmer marine environments would have come from further up the continental shelf, and the fossils from deeper and colder marine environments likely came from the canyon itself. Sedimentary structures found in the rocks here also indicate movement of sediments and water, further supporting the idea that this area was formed through movement of some kind. Since the landslide, the debris and sediments have been lithified and uplifted through tectonic activity. There has been a degree of weathering and eroding, but what remains is still a fascinating glimpse at the environment that once was. This kind of unique geological formation is absolutely worth taking a look at. It's so fascinating seeing the mishmash of all the different shells and sedimentary structures. While you're there, you can look out over the water and ponder what's going on down under the sea that we'll only discover when the water recedes or tectonic activity uplifts the sea floor again.